Good morning, everyone. Thank you for joining us today for the Introduction to Efficient Lighting and Controls webinar. My name is Beth, and I will be co-hosting today's webinar. I'll be monitoring chat and conducting polling at the end of the webinar. Today, we will be covering highlights from our half-day seminar, Introduction to Efficient Lighting and Controls. We hope that after today, you will be able to understand some of the fundamentals and apply them at your facility to help you save money and energy. We also want to thank our sponsors, the Energy Trust of Oregon and Northwest Energy Efficiency Alliance. Our customers let us know that they appreciate that we are aligned with these organizations, and which helps to eliminate any confusion regarding energy efficiency and renewables. Before I introduce the presenter, I would like to show you some tools you'll be using during the webinar. To the right of your screen, you will see several windows: the participants window, the chat window, and the polling window, which will appear at the end of the webinar. If you have any questions during the webinar, you may submit them through chat to me, the host, and the instructor will answer them at the end of the webinar. This will be an informal session today, so if you would like to share an example or have a question you would like the instructor to address immediately, please feel free to raise your hand using the Raise Hand icon at the bottom of the participants window. At the upper left-hand corner of your screen, I'm going to highlight it here for you. Under the Quick Start tab, you will see some annotating tools. The presenter, the tools you'll see are an arrow tool, a text tool, and a highlighter tool, and a marker tool. The presenter will use these tools on specific slides during the webinar, and we'll let you know when to use them. Your presenter this morning is Mark Whitney. Mark has more than 16 years of professional lighting experience at PGE. He currently provides technical lighting support for commercial and industrial projects of all types and sizes. Mark also conducts site visits to review or recommend lighting upgrade strategies, concepts, and appropriate technologies. Mark is lighting certified through NCQLP since 1998, and he is an Illuminating Engineering Society North America member, past president of the Oregon section. Mark is also a LEED accredited professional. Now, without further ado, I'm going to hand the presentation over to Mark.
Thanks, Beth. And welcome everyone to today's lighting webinar. I'm confident you'll find today's presentation to be helpful, and I'll do my best to make it interesting as well. As Beth mentioned, one of my favorite things to do at PG is working with commercial industrial customers to help them with their lighting efficiency projects. So I plan to share some of my favorite tips and suggestions with you today. Here's today's agenda. The main themes will be saving energy, saving money, and providing better quality lighting through a lighting upgrade project. So throughout this webinar, I want you to think of a lighting upgrade application at your business site, or just pick one that you're interested in, and it will help with the webinar today. So the goal today is to supply you with information about lighting and energy efficiency that will make a difference at your place of business. So we invite your active participation today. One of those ways is by using the annotation tools that Beth mentioned that are on your computer. And I'll ask them to use them on the next slide. And we'll do our best to answer any questions you may have, and we plan to leave 10 minutes at the end to answer those questions. Here are the key learning objectives for today. So please use one of your annotation tools, maybe the arrow or just a drawing tool, to indicate to me which one of these are of most interest to you today. During the early part of the presentation, we'll focus on how to get light to the work plane effectively and efficiently. And throughout the presentation, I'll share several energy-saving lighting upgrade applications. The focus will be on retrofit, but new construction applies also. Toward the end, we'll go over how to save energy with controls by focusing on occupancy sensors today. And after you've learned a few things today, I'll let you know how you can get help with your lighting upgrade project. Great. We'll definitely talk about controls today. Thank you. Let's begin by defining what light is. Essentially, light is radiant energy that we can see. And light is light whether it's from the sun, fire, or electric light sources. But there are many variables about light, and we'll discuss a few of those today. Normally, we're looking at reflected light, unless you're a lighting geek like me that's looking up all the time at light fixtures. And our eyes are designed to be sensitive to this energy. This radiant energy can be represented visually by the electromagnetic spectrum. There's a very small band of visible light that our eyes are sensitive to, from around 380 nanometers up to around 770, 780 nanometers. As you can see, all of the colors of the rainbow are represented by this electromagnetic spectrum. Important thing to know is that light quality is very much related to the amount and intensity of the light spectrum in a particular light source. Our eyes detect visual images on the retina located at the back of the eye. We have these photosensitive receptors, and they allow us to distinguish color and light intensity. So the rods that are distributed fairly evenly and throughout the retina allow us to distinguish between light intensities at the lower light levels. It's important to know that we have very few color cues at low light levels. The cones, on the other hand, are mainly focused on this area of the eye called the fovea, roughly about a 2-degree view of optimum vision. That's where our acuity is, and that's where we want to focus on when we're looking. That's where our acuity comes from. So that's important to know. So other rays don't help us nearly as much if we're looking for detail. We're going to look at a couple metrics today. The first of these is the color rendering index. It's one of the ways that we can quantify color quality. This indicates the effect of a light source on the color appearance of objects. It's not a perfect metric, but works pretty well for most sources. It's not as good with LEDs, however. The sun is considered a perfect 100, and incandescent sources for indoors usually around 97 or better. This is why retail stores like to use halogen track lights. High pressure sodium is an example of a very poor CRI light source. Its CRI is near 20, which is very, very yellow. A CRI of 85 or better is considered to be very good. Your better quality fluorescent are going to be in this range. The colors you see on the bottom of your screen are the ones that are used to score and grade light sources. The more accurate they render these colors, the higher the score. But it's important to know that while good CRI is a good thing, not every task needs a high CRI. Retail, art museums, definitely. Warehouse storage, maybe not as important. The other metric we're going to talk about is correlated color temperature, or just color temperature. It is measured on a scale called Kelvin and is represented by the letter K. This metric indicates the relative warmth or coolness of a light source. It's very subjective. Most people's skin is going to look better under warmer sources. And why is that? And that is because there's more red in the light source, and people tend to look better with red in the light source. However, most tasks can be seen better under cooler light sources, and that is because more blue in the spectrum helps make our pupils smaller, allows us to see more clearly. There's fewer aberrant rays, the rays that are not focused on that 2-degree view of vision on the fovea. Another important thing to know is that higher color temperature lamps may also allow for energy savings for certain applications, especially those that have a lot of detail and where acuity is important. As you'll see on this slide, there's a big range in color temperatures. So I want to have you use your annotation tools in a minute. So get your tools ready. As you can see, the larger the number, the cooler the light source. And all sources have a range of color temperature. So for instance, down here, when we're looking at incandescent and halogen, they're focused between around 2700 and 3000. whereas compact fluorescence and fluorescent have a very large range. They go below 3,000, and they can go up to 6,500 or even 8,000 or higher in some cases. So if you can indicate with your annotation tool what color temperature is going to be best for, that you think will be best for the application that you're thinking about today. We have 3,500. Now, fluorescent sources vary their color temperature by adjusting the mixture of phosphor coating used to make white light. Although phosphor appears white on every fluorescent lamp, there are variations that transform light warmer or cooler. All right, someone likes the sun. Okay, thank you very much. So let's turn our focus now on some common lighting terms that will help us today. And it will let us know how we can get light to where you want it in an efficient way. So getting light where you want it begins with a light source. And for electric light sources, you're going to need some power, conveniently supplied by Portland General Electric. This is known as watts, and the output on a light source that is illuminated is lumens. And the efficiency of a light source is more accurately known as efficacy, and it is stated as lumens per watt. Think of miles per gallon. Now, the place where you want light to go is known as the work plane. And getting light to the work plane in an efficient manner saves energy and money. So a high efficacy rating, that's a good place to start. So let's look at some common light sources and see how they compare in efficacy. If you look here at incandescent, you can see very clearly it's very low on this scale. If you go to halogen, it gets better. If you go to halogen infrared, which is the best incandescent source, that gets better. And as you can see, every light source has a range of efficacy. The screw-in compact fluorescence has a range hovering around 50, where the pin-based overall are a little higher and can be as high as 75 lumens per watt. Your T12 magnetic, not very good, maybe around 60. Your T8 fluorescent and your T5s are going to be better than any T12, and the lumens per watt can be as high as 100. One thing you're going to notice here is that some of these sources have room for improvement, such as metal halide and light-emitting diodes. LEDs have the most potential. Some say that it could even have 200 lumens per watt someday. Now keep in mind that efficacy is just the starting point of our light journey. Next, we're going to see fixtures that allow, we're going to see which fixtures allow the most light to actually escape the fixture and have a chance to reach the work plane. So efficiency in a luminaire is expressed as a percentage. So picking the right one is going to be a very, very important thing. However, the most efficient may not necessarily be the best. So here we have a one lamp strip fixture, 95% efficient, but as you can see, the light goes everywhere, and that may not be what you want. A parabolic fixture, on the other hand, might only be about 65% efficient, which is not good, but it's going to be focusing the light down on the work plane where you want it. So even though the efficiency could be less, you could have actually more usable light on the work plane itself. And then, of course, there's the appearance of the fixture as well. So as a general rule of thumb, the more light control you have, the lower the efficiency of a light fixture. So when light hits an object, three things can happen. Number one, it can be reflected from that object, and it will be absorbed to some degree. And if it's a semi-transparent material, some of the light is actually going to go through. So why are some fixtures more efficient than others, even though they may look a lot alike? The answer is that we lose some light every time it strikes a fixture surface or goes through a semi-transparent material like a lens. So would the color of walls and ceilings in a room make a difference in getting light to the work plane? Absolutely. Light is also going to be reflected off walls and objects in the room. Only some of the light rays reach the work plane directly. Others are going to take a more indirect path. So an energy saving tip is to use lighter surfaces and on your walls, floors, and ceilings, and also have more reflective surfaces in your fixtures. So foot candles represent the average amount of light spread over a work plane surface. So it's the amount of light from one candle, 1 foot distance, 1 square foot in space. One thing you're going to notice here, as you get further away, as you get, in this example, as you get twice as far away, 2 feet instead of 1 foot, instead of having a half a foot candle, you have a quarter of a foot candle. And that's because light is affected by the distance squared. So very important, a 10-foot ceiling can make a lot of difference over an 8-foot ceiling, even if it's only a difference of 2 feet. Now the work plane can be your desktop, could be the floor, perhaps a whiteboard or retail display. So the Illuminating Engineering Society publishes a lighting handbook, and they group light levels in categories. Just so point of reference, orientation and simple visual tasks, just getting around, could be less than 1 up to around 20-foot candles. Your common visual tasks, like reading, are going to be in the range of 30 to 75-foot candles. And then you have special visual tasks that could be inspection or all the way up to brain surgery. And that could go up from 100 to about 2,000-foot candles. In case you haven't seen a foot candle before, I've got a picture of one. Okay, so we finally got our light to the work plane, and that's great. But we also need to consider what happens to light over time. All lamps are going to lose light over time, some much more than others, and this needs to be accounted for. This graph shows you the depreciation curve for T8 and T5s, which are the better fluorescent linear lamps today, versus the old T12. And it's pretty clear from this graph that T12s lose a lot of light over time, or your T8s and T5s will keep that light. And that's important because with T12s, you used to have to overlight a space to allow for that depreciation, or if you didn't do that, then you have to accept lower light levels as the lamps get older. So a good light source is going to maintain about 90% or so, good rule of thumb. Now in this graph, you're going to see some other light sources besides, I know it looks like a bunch of spaghetti here, but the point is that we have a lot of light sources like T12 VHOs, mercury vapor, metal halide, your 8-foot slim lines, they lose a lot of light over time. So if you're using these, you have to account for that. Now there's other depreciation factors besides lamp lumen depreciation. Most of these involve dirt associated with getting on the lamps, the fixtures, and the room surfaces themselves. So another good design concept to know is how far apart fixtures should be to give us even illumination for different ceiling heights. So I want to give you a heads up. I'm going to have there's going to be a little quiz on this page. So get ready to answer the quiz. So this metric is known as spacing criterion, and it's the ratio used to calculate the maximum recommended installation spacing to obtain an even pattern of light. And this number is going to be found on fixture specification sheets. So in this example, the spacing criterion is 1.1. So we'll want to space these downlight fixtures, in this example, no more than 11 feet apart if we want even illumination. So in this case, it's pretty easy math. So what if the spacing criterion was 1.2? This is the quiz. So how far apart should the fixtures be spaced? A spacing criterion of 1.2. And what I'd like you to do is point to what you think is the answer. So proper spacing can help us save energy. And how you can do that is by having proper spacing, not having them too close together, which is going to give you more light than you need, more fixtures, more energy. Now keep in mind that this criterion applies to relatively open spaces. If there are a lot of high cubicle walls or partitions, you may want to space fixtures a little closer together. So no one has the right answer yet. Does anybody want to try one of these other answers? Spacing criterion of 1.2, ceiling height of 10 feet. All right, we have a winner, 12 feet. 1.2 times 10 is going to be 12 feet. Okay. We had a little math. We still have a little math to go. So in this section, we're going to discuss two common lamp families, incandescent and fluorescent. But first, some terms that will help us describe lamps. Unfortunately, as I said, it does involve a little bit of math. The letters are going to designate the relative shape of a lamp, while the numbers designate the maximum diameter in eighths of an inch. So here we have T12, T8, that stands for tubular, 8/8 of an inch. That's an easy one. T5, 5/8 of an inch. Here we have G for a globe, 38. Here we have a flame lamp, and A just stands for arbitrary, and a common lamp is A19, which is 19/8 of an inch in diameter. Okay, I think you get the drift. So incandescent hasn't fundamentally changed since it was invented, so why do we use them? They're inexpensive, you can get them anywhere, people know how to use them, the color rendering is good, and maybe one of the most important things is that they're easily dimmed. But obviously they have a lot of disadvantages. Efficacy is low, it's more of a heater than a light source, the lamp life is very short, and recently some laws have been passed to ban certain types. Important thing to know is that halogens, if we talk about halogens, this is another type of incandescent lamp, but it's going to perform better than standard incandescents. So now that these new laws have taken effect, you're going to have three replacement options. One is going to be one that saves about 25%. This is your energy-saving incandescents, which are halogens. And compact fluorescents that we're familiar with save about 75%. And the new kid on the block, LEDs, that save as much or more than compact fluorescents, but they have a much longer lifespan. As you can see in this little chart, you can compare the three. And you can see that the energy-saving incandescents still have a relatively short lamp life. CFL is much better. LEDs, by far the longest lifespan. Now this is going to be important for applications where you have long hours of operation. Otherwise, a CFL may be your better choice. LEDs are relatively expensive, but the prices are coming down. Incandescents dim well, CFLs not so good. LEDs, some yes, some no. Color quality, incandescents is excellent. CFLs, very good. And I'd actually change LEDs to excellent from very good. They're much, much better than they have just a few years ago. So here's some examples from GE, Philips, and Sylvania, the big three. Some alternatives besides the incandescent is compact fluorescent, and they come in different sizes and shape. This one at the top is pretty interesting. This one is actually a hybrid. It actually, if you can look right in the middle there, there's actually a halogen capsule that turns on right away. One of the objections with CFLs is that they don't come to full brightness right away. This bulb will come to full brightness after the CFL portion has warmed up. After the halogen has warmed up the CFL, it comes on and takes over and operates very efficiently. But it's a little bit more expensive. LEDs are ones that can have the longest life, save the most energy, and they've just started to have some that are available in 100-watt equivalents. LEDs are also available in PAR 30s and 38s that are used in retail applications. These were also affected by legislation, And in order to get a qualifying complying lamp, it's going to have to be an infrared version to comply with the new law. But much better, use an LED power lamp. Okay, we're going to move on to fluorescent. Most of you are familiar with T12s. They have magnetic ballast. They use 34-watt lamps called energy savers. Although they have very poor color quality, they don't like the cold. And the magnetic ballast that operate them, manufacturing ceased a couple of years ago. And in July of this year, most of the common T12 lamps are also phased out. You're still going to be able to get some lamps, but they're going to cost more, and none of them are going to save you any energy. There's no good reason to use those at all. So what you want to use is high-performance T8 lamps and ballasts. Sometimes they're called super or premium. It's simply an improved version of the standard T8. The high-performance electronic ballast is going to operate the lamps more efficiently. And when you combine these, you get a high-performance system. So savings of 40 to 50% over T12 is very common. It's important to know that in our service territory, you're going to have to use high-performance lamps and ballast in order to get an incentive. And if you want to find out if your lamp is high performance, this is the website you can go to. You can also use reduced wattage T8s, and these are another form of high performance lamp, but they give off less light. So first, let's look at relamping. If you have an existing T8 fixture, you can simply replace your standard T8s with reduced wattage T8 and save about 10%. Really easy. They look just like other T8s. You just have to read the label. But keep in mind that you have to use these in conditioned spaces or enclosed fixtures. So this is an especially good strategy if the space is currently overlit. But retrofitting using reduced wattage T8s is going to be a much better option. This is going to include a new ballast and other modifications. Obviously, if you have a T12 system, you can't just stick reduced wattage T8s in because the ballast is not compatible. So retrofitting is a good application if you have a T12 or if you have an older T8 system, let's say 10 years old or older. The ballasts are starting to fail. You're going to need some new ones anyway. And if you're overlit, again, this could be a good strategy. But an important thing to remember is that you want to consider the full wattage high-performance T8 lamps first. And that is because it's easier to reduce the number of lamps in retrofitting. For example, you could go from a 4-lamp fixture to a 2-lamp fixture using the full wattage high-performance T8s. So what about T5s? They're different. They're thinner, 5/8, as we saw earlier. There's two basic types. There's the standard T5, and there's one that's used quite often in indirect lighting and high bays, and that's a high output version of the T5. But these don't fit in your standard T12 or T8 lamp holders, and that's because they have a different bipin and they're shorter, so they're not going to go in the same fixtures that T8s or T12s do. So it's really not meant to be a retrofit lamp. It's meant to go in new fixtures. And the best applications for T5s, I feel, are your indirect fixture, your advanced lens fixture. These are ones that have been designed around the lamp to get more light out of the fixture, and then high bays. Fluorescents have improved to the point where you can get light from very high distances down to the work plane. So even though I've mentioned T5s in this example, keep in mind that high-performance T8s work just as well and often better in all three of these applications. So the question you might have with a fixture is replace or retrofit. So some of the things that you want to take a look at is the reflector. You can see in this example, it's pretty dirty, not very much light is going to get out of this fixture. Now, if the fixture was in good shape, even though these lamps have darkened ends, which shows that they're end of their life, if it was a good fixture, you could just replace the lamps. But it's a good time to be thinking about replacing. These lamp holders are probably pretty old. They get brittle from the heat, and they're going to have to be replaced. So just using what I've talked about so far, a lot of you might think, well, yeah, let's just replace this fixture. But don't be in such a hurry to do that. This fixture could be retrofitted. And here's one of the ways that we can do that. So as bad as that last fixture looked, you could retrofit it. So it might have had these 8-foot slimline lamps. It may have had HO or VHO, as you remember, have very steep lumen depreciation. So we want to replace each of these 8-foot T12 lamps with 2 4-foot high-performance T8 lamps. The reason we want to do that is that the 4-foot lamps have the best performance. They have the longest life. You can standardize your lamp source at your place of business. They're easier to handle. Those long 8-foot lamps, it's like carrying a ladder on your shoulder. It's just very awkward and difficult and tough to replace in fixtures that are high up. So what you want to do is you have a kit, you attach it to an old channel, maybe you have a reflector on it as well, and you're going to have new lamp holders. So it's going to make that fixture look just like new. However, sometimes it's going to make sense to install an entirely new fixture, especially if you're way up in the air on a lift. That can be a little challenging sometimes. Okay, here's another common fluorescent fixture, and it has some problems. So there's some clues here that are going to tell us what we might want to try and fix. So if any of you want to indicate some areas of concern, feel free to do that. But I'm just going to jump right in here. First of all, you'll notice that we have an empty lamp holder. This fixture used to have 4 lamps, now it only has 2. They may have chosen to do this because the space may have been overlit, maybe a ballast burned out. This fixture is going to have 2 ballasts. You're going to have one here and one here. So we have a question here. It says, I think it depends on how you define fixture. Well, the fixture, we're talking about this whole thing. We're talking about the housing, the lamp holders, the lamps, the ballast cover. The whole thing is going to be the fixture. So often it needs to be replaced, but sometimes we can save it by retrofitting it. So again, these lamp holders are probably old. The housing is discolored. If you look up here, we've got a gap. Very often these latches are plastic or they get bent, and that turns into a problem. So all that leans towards perhaps getting a new fixture. And there's no lens. So think about fixtures in your facility. What would you do? So assuming you can retrofit this, here's a couple options here. You can have a recessed troffer kit. This is going to include new lamp holders. And if you look in this illustration, if you can think back to that last picture, if you went to 2 lamps, you could choose between either the inboard or the outboard lamps, and they're not going to be centered in that fixture anymore. One's going to be too close to the middle. If you leave the outside ones, they're too close to the outside. With a reflector kit, you're going to have them repositioned more where they should be for a 2-lamp fixture. And if you have a kit that has a reflector, like this illustration, you're going to make that fixture more efficient. More light is going to get out of that fixture. Now, a way to go one step further is you can use an advanced lens retrofit kit. So besides all the hardware on the left, you're going to get a new lens that gets more light out of that fixture. Sometimes you can even go all the way down to just one lamp and still have adequate light on the work plane, especially if it was overlit to begin with. So to summarize, if you have any T12 fixtures, you want to get rid of them. You always want to go with high performance, whether that's the full wattage or the reduced wattage, but consider the full wattage before looking at the reduced wattage. And that's because you can often reduce the number of lamps. So rule out retrofit options before considering new fixtures and decide if lower light levels would be appropriate. Sometimes you need more light, but in my experience, most spaces are overlit. So next we're going to turn our attention to controls. And because we have limited time, we're just going to talk about occupancy sensors. Most of you are familiar with this technology. They turn lights off or lower when no one's around. Most people have had maybe a less than perfect experience with occupancy sensors, but I want you to know they're getting smarter, more reliable. But it's important to pick the right one for your application. This one replaces a wall switch. This one would attach to the ceiling. And this one would attach to a high bay fixture. So passive infrared is one of the more common technologies. Most important thing to remember about infrared is that it needs line of sight. It can't see around corners or if there's an obstruction. And as I mentioned before, it can replace a simple switch, or it can be a ceiling sensor type of occupancy sensor. But because they don't see small movements, if you get further out, you can see that there's more distance between the infrared rays going out. So the further away you are, the more likely it is to turn off when you don't like it. So sometimes you have to do the big wave. But the passive infrared are the least expensive type of sensor. And here are some of the applications that you can use. Small private offices, again with no obstructions, open offices, open restrooms without stalls, hallways and aisles, and your fixture-mounted high bays are going to use infrared. Ultrasonic is another technology. It works a little differently. They detect a disturbance in the force, especially as you're moving away from the sensor. That's where it's going to detect you the easiest. And the sensor has one port here that shoots out the waves, and the other one receives the waves, and it's looking for something that's interrupting that wave. These are typically more sensitive, and they're more sensitive to false ons. And these are best for rooms that have a door that's normally closed. If I didn't mention it, it's more expensive. Applications, large conference rooms, storage spaces with obstructions. Now, sometimes it makes sense to combine two sensor technologies to give you the best performance. So with the dual technology, the lights are only activated when occupants are detected by both technologies. So this helps eliminate the false ons, and then either technology will keep the lights on, and that's going to reduce your false offs. As you can imagine, since you're combining two technologies, this one's going to be the most expensive. Here's some applications. Classrooms is very common. Conference rooms. You have a restroom with stalls or a small office with obstructions. Sometimes this technology is paired with acoustic technology instead of ultrasonic. So you'll have infrared and acoustic. I call this your swearing activated sensor. So imagine you're in the restroom and you're there too long and the lights go off. You might say a few choice words, and good thing is if it has an acoustic technology, it's going to turn your lights back on, at least for a little while. Okay, enough about that. So how much can you expect to save? So I'll talk about a few of these, but if there's a particular one that you would like to talk about, please use your arrow or your annotation tool, and I'll talk about that one. With offices, private offices.
Mark, I'm
Yes.
going to interrupt you for a second.
Sure.
I know some people entered in a little late, and I'm not sure that they know where the annotation tools
Okay.
are. I'm going to highlight them here on the screen, or rather I'm going to draw underneath them. So you can see there's an arrow and a text tool and a couple other things. So that's what Mark is referring to, and he says annotation tool. Thank you.
Thanks, Beth. Yeah, an arrow or your pencil probably work the best. So offices, you can save about 25%, 50%. With private offices, open offices, it's not quite as much. There's usually a little bit more activity. Another thing about occupancy sensors that's important to know is the ownership of the space. If you have a private office, it's your space. You know when you're leaving, when you're coming back, so you're more prone to turn the lights off by yourself. If you're in a conference room, maybe a building, maybe it's not your building, maybe you're visiting someplace, and you don't know if you should turn them off or not. Or you just get lazy and you want to have occupancy sensors do that for you, which is one reason to use them. So restrooms is another common way. Warehouses is the last one, if you can't see that. Warehouses, you can save a lot of energy. There's some places in warehouses that don't get visited all day long or even for days on end, yet the lights in that aisle might be on. So savings of 75% is not uncommon for warehouses. Great place to put fluorescent fixtures with fixture-mounted infrared sensors. So to summarize lighting controls, they work very well if you specify the right type. And here's your three types: infrared, that need line of sight; ultrasonic, sound; dual, that uses a combination of two technologies. And you want to have the right type: wall switch, ceiling, fixture mounted. Install them correctly, right location, pointing in the right direction, kind of like laying turf, green side up. Sometimes it's obvious. And commission them. What we mean by commissioning is that most sensors can be adjusted in some way. You can adjust the timeout setting all the way from 30 seconds up to 30 minutes in some cases. You don't want to have 30 seconds for a fluorescent if it's hooked up to fluorescent, because it's going to burn out the lamp. But if you have LED, they don't mind being switched off, so you could have more frequent timeout settings. Sensitivity, how sensitive that particular sensor is. Field of view, where that sensor is looking. That can be adjusted on most sensors. Again, great savings if it's done right. And if you want more information on controls, because we just touched on this topic today, the Lighting Controls Association has more than you ever want to know. They are an excellent resource for controls. You can take a module of courses on all types of controls, and I highly recommend it. Okay, so now you've hopefully identified some opportunities in your place of business. And if you're in our service territory, you can get a free consultation from myself or one of our outreach specialists. You can go to our website as a place to start. Or if you want to know more about saving energy at your facility and you have a commercial facility, you can contact Paula Conway. If it's an industrial facility, John Maloney, and here's his contact information. The incentives that you can get in our service territory include some standard incentives. Some examples of these are high-performance T8 lighting system upgrades. Talked about going from T12 to high-performance T8. But even if you have an older T8 system, often you can save enough energy to go to the high-performance system. If you have downlights that are incandescent, you can put LEDs in their place. If you have a retail application, or if you have any kind of track lighting, the screw-in LED par lamps is a great application. Up until now, there hasn't been a good alternative for halogens in track lighting and those type of applications. And there's incentives for lighting controls as well. So if you go down the list that you can see on the Energy Trust website or some of their program information, if you don't see your particular application, there are custom incentives for non-standard measures. High bays is a classic example of that, and you can get some incentives for that. So you can go to the Energy Trust website, or again, contact the PG representative and we'll help you out. To qualify for an efficiency project, you need to qualify it. One is it needs a payback of greater than a year. Project savings need to be 25% or more, and it needs to pass a cost effectiveness test for the particular measure that you're looking at. And that's all built into the software. Also, if you're going to use linear fluorescent, you have to use approved lighting product. We mentioned this earlier, the Consortium for Energy Efficiency has a website, and there you can find a list of linear fluorescent that is qualified as a high-performance product, both the lamps and the ballast. And that's updated usually about every 2 weeks or so. If you have LEDs you'd like to use in your project, these need to be approved as well. So the Lighting Design Lab they keep a list of ones that are approved by the Energy Trust, and they also have links to the Design Lights Consortium and Energy Star for their approved list. But they also have a list that is like an interim list that you can have products for a year. Oftentimes, very good products aren't on other approved lists because they haven't gone through the 6,000 hours or so of testing needed to get on these other lists. So Lighting Design Lab has an interim list for LEDs. Very important thing, your project must be pre-approved. So to summarize, if you have a T12 system or an older T8 system, you can go to the high performance using either the full wattage or the reduced wattage T8s and ballast, or new high performance T8 or T5 fixtures. Those would qualify as well. If you have incandescent bulbs, you can go to the energy efficient incandescents, which are these ones that look like regular bulbs, but they're actually halogens inside, compact fluorescents, or light emitting diodes. And if you also have par lamps, incandescent par lamps, some of your standard halogens, you can go to the par 30, par 38, the directional LED sources. If you have areas that are often vacant, be sure to look at occupancy sensors. So there's a lot of upgrade options that we didn't have time to cover today, just because we just don't have that much time. But hopefully this gave you a good introduction. So many of the things that we didn't cover are going to be covered in some upcoming lighting seminars. On September 18th in the Clackamas area, I'll be doing a 3-hour seminar to talk about applications that we talked about today, as well as many others. And it's going to be more of a workshop. If you're more interested in LEDs, there's going to be an LED seminar coming up in October, one in Salem and one in Portland. Additionally, there'll be a webinar on LEDs that I'll be doing on October 9th if you're interested in that topic and want to listen in at your place of business. So now I want to turn it over to Beth for our question and answer portion. So, Beth?
Thank you, Mark. We want to remind you of the upcoming webinars that you see on your screen here. The first one that occurs next week, September the 5th, is Energy Efficiency for Small and Mid-Sized Business. This is a new webinar for us, and we hope that you'll be able to join us for that. And as Mark mentioned, there will be an LED webinar on October the 9th, as well as this list. For a complete list, please visit our website at portlandgeneral.com/classes. Before we proceed to the question and answer period, I wanted to remind you that you can still submit questions to me, the host, through chat. And within a few days, we will send you a follow-up email with the recording of this session and the PDF of the materials. I'd like to draw everyone's attention to the feedback survey to the right of your screen. Please take a few moments to complete the polling survey during question and answer. We really value your feedback, and we will use it to improve our future webinars. And now for the question and answer portion of the webinar. Mark, we had a question about CRI and color temperature, and that was before you had a chance to answer the question, and then you answered it. But I think it might be a good idea to remind people.
Can I mute myself here?
You're unmuted now.
I am?
Yes,
okay.
you are.
All right. I was looking for the unmute button. It disappeared on me. Okay. So, should I go ahead and read these questions? Okay. So the first question is, how are color temperature and CRI related? They're somewhat related, but they're actually two different metrics. Color temperature has to do with the relative warmness or coolness of the light source itself, whereas CRI has to do with the accuracy of how well a light source renders colors on an object that you're looking at. So something could have a very cool color temperature, and it could also have a high CRI, or it could have a low CRI. So they're very, very independent. They both have to do with color quality, but they're really two different metrics. So the second question on the T12 is that I'm hearing they're being canceled. It says here, is there a date to when they will no longer be available? And we did have the date there of July. Actually, it was July 14th is the actual date. So that's in the past. But it's important to know that you can still get the standard T12s as long as they're still in stock. Some people, I'm sure, stockpiled some T12s just like they did with the 100-watt light bulbs. Some hoarders out there. So even though the standard T12s aren't going to be available, there was an exception. There's a loophole, so to speak, on the T12s. No surprise there, I guess. But if you can have a T12 that has a color rendering of 87 or higher, which is higher than most standard T12s, you can go ahead and use that lamp. So you're not going to save any energy. You will get better color rendering, but you're going to be paying more for that lamp. And one reason is that those lamps need a lot of phosphor, a lot of the rare earth phosphors that are in short supply. In China, they kind of cornered the market on phosphors used for lamps. Became very expensive and hard to get. The T8 lamps were affected as well. That's affected the lamp price for T8s. But since T8s are much smaller in diameter, the surface area is probably only half as much, so they only need half as much of those phosphors. So the larger T12, higher color rendering lamp is going to be more expensive because it needs more of those phosphors in order to meet the 87 CRI requirement. And there's some other exceptions for T12s, residential use, and so they will be available, but not your standard T12 that most commercial applications have been using. So another question says, are there LEDs that have as good, if not better, CRI than incandescent? And this is in regards to a retail application. So the CRI for LEDs is very good. It's typically not as high as incandescent, But even though incandescents might be 97, 98 CRI, they're typically weak in the blues. So if you have things in your store that have that you want to have blue very accurate, it's not going to score as well. Where LEDs are usually a little bit better in that blue category. Also, CRI is it's not the best metric for LEDs. There are some LEDs that have a relatively low CRI. Maybe they have a CRI of 70, but they actually make things look really good. So you can't go by CRI alone with LEDs. They're better at rendering saturated colors. And there's a new metric that's coming out called the color quality scale that hasn't been adopted yet, but when it is adopted, I think it will be, or something similar, that you're going to find that LEDs are scoring much higher than you see them scoring today. But I've seen them in retail applications. They render colors really well. You can get ones that are 90 CRI or better. And so I really wouldn't hesitate to try out CRIs for retail applications. But as I say, proof's in the pudding, so I would get a sample, put it in your store or your place of business, try it out, and see how things look. I think you're going to be pretty surprised. We have time for maybe just one more question.
Thanks, Mark. We do have one more question. Actually, we have two more questions, but we'll ask the first one here. Please review retrofit options for T12 fixtures.
Okay, the different options for T12 fixtures. There's actually a lot of options, and which is going to be a good reason to come to the seminar next month. But in general, you want to, obviously you're going to need to change the lamps and the ballast in a retrofit. I highly recommend changing the lamp holders, even though you could use the existing lamp holders. But from my experience, if it's a T12 fixture, it's been there a long time, there's been a lot of heat in that fixture, the plastic gets melted or gets brittle, and it's a very important point of contact with the lamp. Some of those get pitted and corroded, so you want to get new lamp holders whenever you do a T12 to T8 retrofit. You want to look at any of the components that might need to be replaced. Sometimes it's, in that case that we looked at, we had a missing lens. If everything else was in great shape, you can get new lenses pretty inexpensively and replace those. Sometimes they've yellowed. They're a polypropylene type of lens, and you want an acrylic lens that doesn't yellow. So sometimes you can swap those out inexpensively. But if too many of the components are no good, then you just want to break down and get a new fixture. Sometimes you'll replace those fixtures one for one, but if you're putting in new fixtures, it's time to consider maybe a redesign. Maybe instead of 12 fixtures for the space, maybe you only need 9. So it's a time to be thinking about that. Again, there's a lot of options with T12s to T8s, and that's why it's good to have someone like myself come out to your place of business, and we can talk about that in detail.
Thank you, Mark. And we have one more quick question, and then we'll be closing the webinar. And again, we'll be sending you the recording and the presentation slides in a couple of days. So, Mark, how does incandescent CRI change if you are dimming in comparison to LED? So, with regards to dimming, how does CRI change?
Okay, when you dim incandescent, the CRI is actually not going to change, but the color temperature will. When you dim incandescent, it goes much warmer. When you dim most LEDs, they either don't change or sometimes they could go a little bit cooler. However, they're developing LED fixtures that can mimic incandescent dimming. that will go warmer. I saw one of these at Light Fair Juneau. Is one that won an award for it. Got recognition for an LED that dims warmer. It goes warmer when you dim it, just like incandescent. And that can be very desirable in applications like restaurants, for instance. But you're also going to see LEDs that can color temperature change throughout the day by adjusting warm and cool LEDs. And this is very exciting. I think you're going to see this as being the future. And this is something I'll, again, talk about in my seminar and probably the LED webinar that I'll do later next month, too. Okay, I think we're out of time.
Thank you, Mark, and thank you all for joining us today. We'll stay online for a while in case any of you have any questions you'd like to ask, but thank you again.